Hi, in this video we are going to learn what natural deduction is and what system of natural deduction we will be learning in these videos. Hi, this is Logic Self-Taught with Dr. Phi. In this video we are going to talk about what natural deduction is. I will introduce a simple example of ordinary reasoning to give you an idea of what natural deduction tries to model. Then we will talk about two different kinds of proof systems there are in logic, axiomatic systems and natural deduction systems. And we will take a look at the set of inference rules we will be learning in these videos. There are 9 of them. Let's look at the ordinary reasoning I mentioned. We are told Eve will go out with Ben if he makes an A or a B in logic. And then we are told that Ben will make an A in logic if N doesn't go out with him. Further, N won't go out with Ben unless Eve invites her to the party. Eve will invite neither Jen nor N to the party. So, you might wonder, will Eve go out with Ben? I mean, if you think about it a little bit, Eve actually will go out with Ben. And we can show that this is so. Let's list what we know. These are the statements that we've been given. We write down the conclusion in pencil at the bottom. What we've been told are our premises, and we'll try to show that the conclusion that Eve will go out with Ben follows from them. We will number the premises so that we can keep track of them. We basically have to see what follows from what we are given. So focus on premise 3 and 4. N won't go out with Ben if Eve doesn't invite her to the party. But we've been told that Eve will invite neither Jen nor N to the party, so it follows that N won't go out with Ben. Consider further statements 2 and 5. We've just established that N won't go out with Ben, but we've been told that if N doesn't go out with Ben, Ben will make an A in logic, so we can surely infer that Ben will make an A in logic. And now focus on 1 and 6. We've been told that Eve will go out with Ben if he makes an A or a B in logic. Now we've established that he will make an A in logic, so we can conclude that Eve will go out with Ben. This is an example of ordinary reasoning that natural deduction tries to model. In a natural deduction proof, each of the steps must be strictly justified by formal inference rules. We will see such rules in a moment. There are 2 types of proof systems: axiomatic systems and natural deduction systems. In axiomatic systems, you are given a set of axioms, tautologies, and only 2 rules, modus ponens and the substitution rule. Let's take a brief look at an example. These are Frege's axioms for propositional logic. I'll show you the proof of one of the theorems, if P then P. However, I'll only note 3 types of moves that are made. One kind of move is to repeat the axiom. The first step in our proof is indeed the repetition of axiom A2. Another kind of move is the application of the substitution rule. The second step here involves the substitution of all occurrences of variable Q with the formula if P then P. The third kind of move is the application of modus ponens. Modus ponens is a rule that allows us to derive the consequent of a conditional if we have the conditional and its antecedent on a different line. We have a conditional in step 3 and its antecedent in step 5, so we can derive the consequent. To complete the proof, 2 more steps need to be done. As you can perhaps see, axiomatic proofs are quite complex. It's quite hard to see what to substitute for what and how to proceed. Moreover, they don't resemble the way we reason. Indeed, this latter fact was one of the main motivations to develop natural deduction systems. There are many different natural deduction systems. 2 main types are taught in the introductory logic classes. Fitch-style or Fitch-Jaskowski style systems typically have 11 inference rules. For each connective, there is a so-called introduction rule and a so-called elimination rule. Moreover, there is the reiteration rule. A very popular natural deduction system, one we'll be learning, is composed of 8 inference rules that exemplify simple arguments. Sometimes the 9th rule, the rule of absorption, is added to them. These rules are quite powerful, but they need to be supplemented by other rules: conditional proof, indirect proof, and the so-called replacement rules. In this series, we will just focus on the 8 plus 1, so 9 inference rules. I will introduce the 8 inference rules first and absorption last. So if you don't have absorption in your system, don't worry. We will learn the 9 inference rules that you see here. Inference rules basically represent valid arguments. So they are all truth-preserving. You can use your favorite method, for instance, the truth table method, to show each of the inference rules represents a valid argument. Now, each inference rule allows you to add a proposition to the proof, marked in green. Each rule requires that you have certain propositions in the proof already, marked in yellow. Those propositions will be either your premises or will have been already derived in your proof. How many and what form these propositions have will depend on the rule in question. Some rules demand 2 propositions for its application, some only 1. Some rules allow us to infer complex propositions. Some allow us to infer simple, or at least simpler, propositions. Some inference rules have only 1 version, some have 2 versions. It's important to note that the variables that occur in the inference rules can be substituted by simple and complex propositions. Another important point is that inference rules don't apply to components of propositions. The connectives that the rule mentions must be the main connectives of the propositions to which the rule is applied. And a final preliminary point is about the order. Sometimes the order matters, sometimes it doesn't matter. When a rule demands 2 propositions to be given, the order in which the propositions occur doesn't matter. In the case of disjunctive syllogism here, it doesn't matter whether you have the disjunction or the negation first. But the order that does matter concerns the order in which the sub-propositions occur. And that is why we sometimes need 2 versions of a rule. Let's look at what a natural deduction proof looks like. We will not go through the proof in details. The proof consists of a sequence of propositions. These are sometimes referred to as the lines or steps of the proof. Some of those propositions are the premises. Usually what you do in a proof, you show an argument to be valid. So you start with the premises of the argument, and then through intermediate steps, you show that the conclusion of the argument follows from the premises by reference to specific rules. And this is the key. Each of the intermediate steps must be justified by appealing to a specific inference rule that is applied to a specific step in the proof that has been justified already. For this reason, the lines are numbered and the justifications appeal to those numbers. This also allows anyone to check how this step was obtained and whether it was obtained correctly, of course. We will also use graphical devices. This is useful in particular later when you learn conditional and indirect proof. The blue line here is the derivation line. Each of the propositions that we derive will stand at that line, and we will also use a premise line that will separate off the premises from the rest of the proof. Okay, I hope that this gives you some idea of what natural deduction is and what we will be learning. For each of the inference rules, there will be 2 videos. In one, we will talk about how to apply the rule and how not to apply it, what mistakes to watch out for. And in the other, we will go through some proofs step by step. I strongly recommend that you watch a video on how to learn natural deduction. And I also recommend my workbook, where a lot of examples are worked out step by step. But most importantly, there are lots and lots and lots of exercises that will help you develop the skills. The link to the workbook is available in the description below. Thanks for watching.